In this module, we're talking about the discovery of the electron and yes, some of the experiments that led up to our current understanding of the electron. So let's start with J.J. Thompson. So J.J. Thompson was the one who was able to prove the existence of electrons. And he did this by studying cathode ray tubes. And what a cathode ray tube is essentially is it's usually a glass tube that has when the glass blower makes it, they pull most of the air out of it. They evacuate it, but not entirely. There's still a little bit of air left in there. And they have one electrode on each end. That electrode is just a piece of metal here and here. And they connect these electrodes through a wire to a power supply, a source of electrical potential. What happens when they turn on this power supply, okay, if it's set up so that this end is the negative terminal and this is the positive terminal, you get a stream of electrons, of negatively charged particles that Thompson called electrons, moving from this electrode to this electrode. What else he did was he took a magnet and he created an external magnetic field with that magnet. Put the say put the North Pole up here and the South Pole down here. And what he was able to do is what happens when you do that is this beam of electrically charged particles of electrons is bent, okay? And so instead of going straight, it curves off and hits down there, or down there. It ends up that a stream of electrically charged particles creates a magnetic field perpendicular to its motion, and that's what interacts with the magnetic field here. But he was able to calculate, based on the angle of deflection and knowing the strength of the magnetic field, what the ratio of the charge to mass of an electron was. So he was able to deduce the ratio. Couldn't get either one by itself, but he got the ratio. And he got this number, negative 1.76 times 10 to the 8th coulombs per gram. C stands for coulombs, which is the unit that of electrical charge that we're going to use. Well, next came this guy, Robert Millikan at the University of Chicago. Okay, after Thompson did his experiment, he set up this really extremely clever experiment. And what he was able to do is from this experiment, find the charge on an electron. And then knowing the charge, of course, you can get the mass just using Thompson's result. So real quick, Millikan's setup was he had an atomizer, like they have on some of those old perfume bottles, and some oil, and he used that to atomize, to make little tiny droplets of oil that he shot into this chamber. Now in this chamber, he had two metal plates with a hole in the top one, and these were hooked up to an electrical potential, a power supply, so that there was a positive and a negative pole. And he also had a source of X-rays, okay, that he shot through the stream of drops that were falling through this hole. Now, what he would do is he would spray the drops in there, and he would count, just looking through this microscope, count how many drops passed, say, per minute or per second or per unit of time. Then he would turn on the X-rays, and what the X-rays do is they create a charge on the drops of oil. They knock off electrons and they create a positive charge. And so what happens is, now that we have something that's positively charged, this negative charge down here attracts it, so it's going to move faster. And it's repelled by this positive charge up here too. So then he turns on the X-rays, does the same experiment, counts how many drops pass per second or per minute or whatever, and from that data, he took a lot of data, but he was able to find the charge on an electron. Now, he was able to calculate the charge on each drop of oil, and they were different. The drops were different size. They had, the X-rays would knock off different numbers of electrons. So he got a lot of data. Okay, so he got the charge on this drop was this, the charge on that was that. What he did was he looked for the smallest common denominator of all those. And he deduced that must be the charge on a single electron, because an electron is a fundamental particle. It's, you can't break an electron down any farther. That's the smallest amount of negative electric charge we can have. So what he found was that the charge on an electron was negative 1.602 times 10 to the minus 19th coulombs, and then the mass of an electron was 9.109 times 10 to the minus 28th grams, or 9.109 times 10 to the minus 31st kilograms. Memorize these guys. They're going to be very useful to know. Okay, so let's do an experiment, maybe illustrate what, give you an idea of how Millikan did part of his calculations. So let's say he did, in one of his experiments, he found that the total charge on one of those oil drops was 9.452 times 10 to the minus 18th coulombs. How many negative charges were on that drop? In other words, how many electrons? Well, all we have to do is take the total charge and divide it by the fundamental charge, the charge on an electron, and that'll tell us how many electrons there were. So it just looks like this. The total charge divided by the charge on an electron. And because we know we can't break an electron down, this is going to be an integer. We're counting individual things. So no matter the sig figs, we're going to round this to a whole number, and we get 59 electrons. And there you go.